The math tells us this is impossible, yet the trajectory of 3I Atlas has just defied 18 separate statistical laws in a row. If natural forces did not build the precision engines we see firing, then we must face the question of what did. Welcome to this special deep dive investigation. Before we analyze the data that is currently baffling the scientific community, make sure you are subscribed to the channel, as the situation with this interstellar visitor is evolving by the hour, and you will want to see what happens next. We begin our analysis not with where the object is now, but where it came from. In a universe of infinite directions, 3I Atlas originated from a specific patch of sky that astronomers know well. The trajectory traces back to within 9 degrees of the coordinates for the famous WOW signal, the strong narrowband radio burst detected in 1977 that remains the strongest candidate for a technosignature in history. While a 9-degree separation might seem wide in a casual context, in the vastness of the galactic sphere, for an object of this magnitude to emerge from that precise neighborhood of the constellation, Sagittarius is the first of many statistical outliers we must confront. It is a direction of arrival effectively shouting for our attention. This arrival vector brings us to the first major geometric anomaly. Most comets from the Oort cloud, or interstellar space, arrive at steep angles relative to the flat plane where Earth and the other planets orbit. The disk of our own Milky Way galaxy is inclined at 60 degrees to our solar system. Yet 3I Atlas approached us on a retrograde trajectory that lies within just 5 degrees of the ecliptic plane of the solar system. It did not drop in from above or below like a typical random visitor. It came in sliding almost perfectly along the same tabletop that the planets move upon. The probability of an interstellar object randomly matching our system's orbital plane, this precisely, despite the 60-degree tilt of the galaxy it came from, is statistically negligible. It suggests an injection vector determined not by galactic chaotic motion, but by the specific architecture of our local planetary system. As we track this object deeper into the gravity well of the Sun, the alignment becomes even more specific. We need to talk about the data from January 22nd, 2026. At 1300 hours, Coordinated Universal Time, 3I Atlas achieved a geometric lock with our planet that models suggest is far too precise to be accidental. On that date, the object lined up with the Sun-Earth axis within 0.69 degrees. This is not just a close pass, it is a rifle sight alignment. This positioning meant that its, which we will discuss later, was directed straight at Earth. For a full week, the phase angle remained below 2 degrees, presenting a perfectly illuminated profile to terrestrial observers. In astrodynamics, we call this a high information pass. It is the kind of trajectory you would design if you wanted your object to be seen, observed, and analyzed by the inhabitants of the third rock from the Sun. A random rock tumbling through the dark does not pause to pose for a week-long photo opportunity with perfect backlighting. This brings us to the mechanics of its flight path involving the Sun. The gravitational deflection of 3I Atlas at its perihelion, the point closest to the Sun, measured exactly 16 degrees. By itself, that number is just a dynamic result of speed and mass. However, when we overlay the images of the anti-tail feature observed before perihelion, a disturbing ratio emerges. The opening angle of that pre-perihelion tail was measured at 8 degrees. The gravitational turn was exactly double the structural angle of the tail, a 16-degree turn for an 8-degree structure. This specific 2-to-1 harmonic relationship between the object's physical shape and its orbital maneuver is a hallmark of artificial control systems, not chaotic geology. In nature, we expect messy fractions, not perfect integers. When a river bends, it does not do so at exactly twice the angle of the width of its banks. But here, the math is clean. The deflection coincidence suggests that the mass distribution and aerodynamics of 3I Atlas, if we can even apply that term in a vacuum, were attuned to the specific gravitational parameters of this solar encounter. We are looking at a trajectory that seems less like a ballistic curve and more like a flight plan. It entered from a region associated with extraterrestrial intelligence history, flattened itself into our specific planetary plane, aligned with Earth for maximum visibility, and executed a turn around the Sun that geometrically mirrors its own physical structure. If we were looking at a single anomaly, we might dismiss it as a fluke, but we are looking at a chain of them. And, as we will see in the next chapter, the timing of this arrival was just as calculated as the path itself, threading the needle between our gas giants with a precision that rivals our best spacecraft navigation. As we established, the path of 3I Atlas threaded the needle of our solar system's geometry with unnerving precision. But the spatial alignment is only half the equation. When we analyze the timeline, the statistical improbabilities compound further. This was not just a matter of being in the right place. It was a matter of being there at the exactly calculated time. The object's entry into the inner solar system was synchronized to interacting with the massive gravitational bodies of our neighborhood without being captured or ejected chaotically. The data shows the object passed 29 million kilometers from Mars and 54 million kilometers from Jupiter. These are safe, non-perturbing distances for a stable flyby. However, the timing was such that 3I Atlas remained unobservable from Earth during its most critical phase, its perihelion passage. It hugged the blind spot of the Sun, hiding its closest approach from our telescopes before emerging into the high visibility alignment we discussed earlier. It is a behavior reminiscent of stealth insertion strategies. Approach unseen, then reveal specifically when positioned for impact. The encounter with Jupiter offers the most specific numerical anomaly in this sequence. Based on current trajectory models, the forecasted perigove distance, the closest point to Jupiter, on March 16, 2026, will measure 53.6 million kilometers. To a layman, this is just a number. To an astrophysicist, it triggers an immediate alarm. Jupiter's hill radius, the distinct region where the giant planet's gravity dominates over the Sun's, extends to 53.5 million kilometers. 3I Atlas creates a trajectory that skims the absolute edge of Jupiter's gravitational dominance, missing the boundary by a margin of less than 0.2%. It is riding the edge of the gravity well, utilizing the maximum gravitational assists available without surrendering orbital authority to the gas giant. Ideally, a random rock would pass at 10 million kilometers, or 100 million. To skirt the theoretical limit of the hill radius, this precisely is akin to a driver drifting a car with one tire exactly on the white line of the road edge for miles. It implies a calculated boundary condition, not a random roll of the celestial dice. This rigorous adherence to optimal flight paths is mirrored in the object's own orientation. We must address the rotation axis alignment. Most comets tumble. They are irregular potatoes of ice and rock, spinning chaotically as jets erupt from random fissures. 3I Atlas is different. Long before it felt the heat of the sun, while it was still crossing the cold void, its spin axis was already oriented. The data reveals that upon entering the solar system, its axis was locked within 8 degrees of the sun. Imagine a top spinning in the dark, light years from a star, yet angled perfectly so that its pole would point directly at that star when it finally arrived. This foreshadowing of the solar encounter suggests a stabilized attitude control. It was keeping its face to the sun long before solar heating could influence its shape or weight distribution. This is the behavior of a gyroscopically stabilized craft, maintaining a specific attitude for thermal management or sensor alignment. This brings us to the thermal anomaly widely known as the insulation requirement. The activity on 3I Atlas, specifically the jet bases we will investigate shortly, shows a binary state of activation. They turn on when facing the sun and shut down completely on the night side. This sounds standard for a comet, but the thermal inertia is wrong. Rock and ice hold heat. When a normal comet rotates into the dark, it stays warm for hours, slowly cooling. The jets on 3I Atlas cut off instantly inside the shadow line and remain dormant for months if the pole is turned away. This necessitates a surface material with exceptional thermal insulation properties, far superior to the porous regolith we see on comets like 67P. It suggests a skin that prevents heat from soaking into the core, or perhaps a mechanism that actively gates the venting. The object treats solar energy not as a passive environmental heater, but as a trigger signal. It collects energy only when aligned and insulates itself perfectly when turned away. So we have an object that arrives with a spin axis pre-aimed at our sun, inserts itself into the system to skirt the precise edge of Jupiter's gravity, and manages its thermal intake with binary precision. It is moving with intention, and as we look closer at what is happening on those sun-facing poles, the evidence for artificiality shifts from mathematical coincidence to physical engineering. The structures we are seeing are not shapeless plumes of gas. They are organized, geometric, and oscillating with a rhythm that looks like a machine heartbeat. Building on this evidence of precise thermal control, we must now examine the physical mechanisms releasing that energy. If the trajectory and timing suggest a flight plan, the behavior of the jets suggests an engine. The structures emerging from 3I Atlas bear little resemblance to the chaotic outgassing of a warming comet. They display an architecture of activity that is geometrically rigid and dynamically stabilized. The fourth anomaly in our investigation is the columnated jet. In typical comets, sublimating ice creates a diffuse cloud, a coma, that expands in all directions. Hubble images of 3I Atlas, however, reveal a sunward anti-tail that resolves into a physical jet with a startling structure. It maintains a length-to-width ratio of 10:1. It is a long, narrow cylinder of material stretching hundreds of thousands of kilometers into space. Crucially, this stream is not being deflected by the solar wind. A tenuous stream of gas and dust should be blown back by the pressure of the sun's radiation, curving into a classic comet tail. This jet remains straight, pointed directly at the Sun, fighting the solar wind upstream. This implies high velocity and significant mass density within the column, or magnetic confinement. It looks less like a tail and more like an exhaust plume from a high-impulse thruster. Within this jet, we detect further signs of active stabilization. This is the sixth anomaly, the jet wobble. Pre-perihelion data shows that the base of this jet does not migrate across the surface as the Sun rises and sets on the object, as we would expect with melting patches of ice. Instead, the jet base is confined to a tight circle within 8 degrees of the Sun-facing pole. It corrects itself. As the object rotates, the jet adjusts to stay locked on the solar vector. I want to pause here and ask you a question. Does a natural ball of ice contain a feedback loop to keep a vent pointed at the Sun? Or does that sound like a tracking system to you? Let me know your thoughts in the comments below, because the complexity only increases from here. We also observe a switching mechanism. This is the seventh anomaly. Dual jets. The object possesses emitters on both poles. Before perihelion, the northern pole was active. After perihelion, as the season changed on the object, the southern pole activated. This transfer of energy was clean and absolute. It suggests a bimodal propulsion or venting system designed to operate along the axis of rotation regardless of orientation. It ensures that a propulsive or cooling force can always be directed sunward. But the most striking structural evidence was captured in January 2026 by Hubble. This is the eighth anomaly, and it might be the smoking gun. We aren't just seeing one big jet, we are seeing a triplet array. The images resolve 3 distinct mini-jets. The analysis shows they are separated by exactly 120 degrees around the central axis. Nature rarely counts to 3 with perfect symmetry. A triangle is a hallmark of engineering. Think of the legs of a tripod or the placement of thrusters on a lander. These 3 mini-jets extend 25,000 kilometers, and incredibly, they wobble. They oscillate plus or minus 20 degrees with a period of 7.2 hours. They are synchronized. They move together. This periodic wobble suggests a precession, a stabilization cycle, or a scanning pattern. Alongside these 3 synchronized mini-jets, there is a fourth structure, the main anti-tail jet, which extends 10 times farther sunward. The combination looks like a main engine surrounded by 3 maneuvering thrusters. To see such geometric regularity, 120 degrees apart, oscillating in time, on a natural body is unprecedented. It implies an internal structure that dictates where and how gas can escape, forcing it into a symmetrical, coordinated pattern. The architecture of this activity is too orderly for the random sublimation of mixed ices. We are watching a system that maintains focus, switches poles, and fires in a geometric triad. And if the structure of these jets is baffling, the material they are spewing out is even stranger. The chemical signature of 3I Atlas is not just rare. It is unlike any biological or geological profile we have ever cataloged in a comet. This connects the structural precision we have just seen to the fundamental question of composition. What is 3I Atlas made of? If it acts like a machine, does it look like one under the spectroscope? The data from the chemical analysis is perhaps the most damning evidence against the dirty snowball hypothesis. We are detecting materials that have no business dominating the spectrum of a natural comet. The 13th anomaly is the extreme nickel abundance. In every comet we have studied since the dawn of spectroscopy, iron is the dominant metal, usually accompanied by standard ratios of cyanides and carbon chains. 3I Atlas flips the periodic table. The gas plume shows a concentration of nickel that exceeds iron. Furthermore, the ratio of nickel to cyanide is orders of magnitude higher than in any known comet. This is not a slightly metal-rich rock. This is a signature resembling refined industrial nickel alloys. In human metallurgy, we use high nickel superalloys for engines, turbine blades, and aerospace shielding because they withstand extreme heat and corrosion. Finding a celestial object that is spewing a specific industrial alloy vapor suggests we are not looking at a rock, but at the ablation of a manufactured hull or heat shield. The physical nature of the dust itself is equally puzzling. This is the 14th anomaly, the particle size in the anti-tail. As we noted, the jet points toward the sun without being blown back. For this to happen, the particles must be heavy enough to resist radiation pressure. Physics tells us they must be larger than the typical submicron dust found in comet tails. However, they also account for 99% of the scattered sunlight. For a swarm of particles to be this reflective, they cannot be large chunks of gravel, they must be fine. The models constrain the size to a narrow window, larger than submicron, but smaller than millimeters. This specific grain size is incredibly uniform. A natural collision or disintegration creates a power law distribution. Boulders, rocks, pebbles, and dust all mixed. 3I Atlas is shedding a monodispersed cloud of particles. This uniformity is characteristic of engineered powders or specific ablation products, not the random grinding of geology. Then there is the mystery of the vanishing ice. This is the 15th anomaly, organic preservation. In August 2025, the SPHEREX mission detected clear signatures of water ice fragments in the coma. It looked, for a moment, like a normal comet. But after perihelion, the ice signal vanished. It did not just fade, it was replaced. The spectra showed a massive surge, a 20-fold increase in complex organics, methanol, formaldehyde, methane, and ethane, along with water vapor. The ice chunks were gone, replaced by a volatile soup of hydrocarbons. This sequence implies that the ice observed earlier was a superficial coating, or frost, that burned off to reveal a core rich in preserved organics. To keep these volatile organics stable during the millions of years of interstellar travel, they would require shielding from cosmic rays. Calculations indicate they would need at least 10 meters of protective overburden, rock or metal, to survive the journey intact. The sudden appearance of these chemicals suggests the protective layer was breached or shed, or that the internal reservoir was opened. We are left with a picture of an object constructed of high nickel alloy, shedding uniform particles, and protecting a core of complex volatile fuels or coolants. This is not the profile of a pristine remnant from the dawn of a solar system. It is the profile of a shielded vessel venting material. And when we combine this chemistry with the raw physical properties of the object, its mass, its speed, and its light, the conclusion becomes unavoidable. The final set of anomalies defies the laws of cometary physics entirely. Given what we now understand about the trajectory, the structure, and the chemistry, we finally arrive at the intrinsic physical properties of the object itself. These last three anomalies represent the most fundamental violations of what we expect from a natural body. They concern mass, light, and speed. The 16th anomaly is the mass-velocity combination. We have precedents for interstellar objects. We saw 1I Oumuamua, which was small and fast. We saw 2I Borisov, which was large and seemingly typical. 3I Atlas breaks the curve. The tracking data indicates a nucleus that is vastly more massive than both Oumuamua and Borisov. It has significant heft, yet it is traveling faster. In celestial mechanics, kinetic energy is expensive. For a random rock to be both incredibly heavy and moving at such extreme velocity implies an energetic event of colossal scale at its origin. It is a kinetic impactor of the highest order. It is akin to finding a freight train moving at the speed of a bullet, whereas nature usually gives us feathers in the wind or slow-moving mountains. The way light interacts with this heavy, fast object is equally unprecedented. The 17th anomaly is the negative polarization. Light reflects off surfaces differently, depending on their texture. Rough rocks, dusty snowballs, and asteroids all have specific polarization signatures. 3I Atlas shows a deep negative polarization never before observed in any comet. This optical behavior is possibly linked to the anti-tail structure or the surface texture itself. Negative polarization often implies a complex scattering structure, possibly a porous surface or a regular lattice that traps and scatters light in specific angles. It adds to the hypothesis that the surface is not natural regolith, but an artificial metamaterial or a highly specific industrial texture that does not exist in our geological catalog. Finally, we have the 18th anomaly, the exception, brightness, and color shift. As 3I Atlas approached perihelion, it did not just get brighter, it surged. It brightened faster than any recorded comet in history, defying the standard inverse square law for passive reflection. It was adding its own luminosity to the equation, or increasing its reflective surface area dramatically. Simultaneously, its color shifted. Most comets are reddish or dusty brown. 3I Atlas appeared bluer than the sun itself. A blue shift in a reflective object implies a pristine, ice-clean surface or specific wideband emission. For an object we know is rich in nickel and organics, to appear blue suggests high-energy phenomena, ion fluorescence, or extreme heat, rather than just the reflection of sunlight off cold ice. These 18 anomalies, taken together, dismantle the coincidence hypothesis. We have an object from the direction of a known technosignature entering on a specific flight plane, aligning with Earth, turning with a geometric ratio, timing its arrival to the day, engaging thrust with stable wobble, switching poles, firing in a perfect triangular triad, spewing industrial alloys, and shining with an unnatural blue light. In science, we look for the simplest explanation. Usually, that explanation is a rock, but when a rock behaves with the precision of a pilot and the geometry of a machine, the simplest explanation involves design. We are likely looking at a probe, defunct or active, that has passed through our system. The data is there. The interpretation is up to us. But the silence of the mainstream on these 18 points is deafening. If you found this deep dive valuable, please hit the like button to help this scientific analysis reach a wider audience. The universe is speaking to us. We just need to learn how to listen. Thank you for watching.